Okay, today we're going to look at independent and dependent events. These are kind of compound events. So there were 5 black socks, 3 red socks, and 1 white sock, probably sitting in a drawer. What is the probability of selecting a black sock, replacing it, and selecting another black sock? Let's take a minute to look at this question. What is the probability of selecting a black sock, replacing it, and selecting another black sock? Well, the probability of the first one happening, there's 5 black socks out of 9 total. Now we replace it and then try to select another black sock. Well, the probability of a black sock is still 5 out of 9 because it's the same setup as we started with. So all we have to do is multiply these two and we get 25 out of 81. We could do a tree diagram, we could do a number of other things, but this is a little bit quicker just to multiply them. Now let's look at this next one. We want to see how it's different. There were 5 black socks, 3 blue socks, and 1 white sock. So far it's still the same. What is the probability of selecting a black sock, then not replacing it, and selecting another black sock? Well, for the first black sock, it would be 5 out of 9. That should make sense to you because there's 5 black socks out of 9 total. But what about this second black sock? How many black socks are in there if we didn't replace one of them? Well, now there are 4 black socks. And how many socks are in there total? Well, if we didn't replace one, there's now 8. So we simply multiply and we get 20 over 72, which simplifies to 5 over 18. So there's a 5 in 18 chance. Now, so what was the difference between these two? Well, this one's what we call, the first one, is independent. It's an independent event. Basically, one thing does not have to do with the other thing. What happened in the first event, the drawing of a black sock, does not affect the second drawing of a black sock. But in this case, we call this one dependent. And the reason we call it dependent is because what happened in the first drawing does affect what happens in the second. If we draw out a black sock and we don't replace it, it's going to affect the second probability. Well, let's look at one more and see if we can't figure it out. Imagine all the letters from Tennessee are on little tiles and they're placed in a bag. What is the probability of selecting an E, not replacing it, and then selecting an S? Well, the probability of selecting an E is 1, 2, 3, 4. There's 4 E's, so it's going to be 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 out of 9. So that takes care of selecting an E. Now we don't replace it, and we're going to select an S. Well, there are 2 S's, but now since we did not replace one of these, it's going to be out of 8. So we should get, if we multiply this upright, 8 out of 72, or 1 out of 9. Now, is this independent or dependent? In this case, it is dependent. And the reason we say it's dependent is because what happened in the first one affected what happened in the second one. There were 9 tiles in the bag, but if you don't replace one, now there's 8. So if you see these keywords, not replacing or something similar to that, that lets you know it's going to be a dependent event. And this is important to do because you'll be expected to recognize this.